Okay, so let's start with this question. Wait. This is the first question. So first question is phenol react with on treatment dilute nitric acid. So tell me, if we treat phenol with nitric acid, here actually it is dilute nitric acid. We get picric acid. See, this is phenol, and if we treat it with the concentrated nitric acid, we get picric acid. So tell me, what is the limitation of this method? 2,4,6 trinitrophenol we will get. We get picric acid, but what is the limitation of this method? Yield is poor. Why is it so? Because phenol is very active molecule. So this concentrated nitric acid can act as an oxidizing agent. Therefore, oxidize the ring. And that's why yield is poor. And to increase the yield, what we do? First we sulfonate it. So we get phenol SO3H at one place, or maybe at 2,4. We get these products, and then we treat it with concentrated nitric acid, so then it will yield is improved. So keep in mind, this is important. But if we treat it with dilute nitric acid, then there is orthonitrophenol and paranitrophenol. So you know, out of orthonitrophenol and paranitrophenol, which one has higher boiling point? Because orthonitrophenol, that is associated, means there is intramolecular hydrogen bonding, and because of intramolecular hydrogen bonding, its intermolecular association is very less. So its boiling point is low, and at the same time it is steam volatile. And if we talk about paranitrophenol, in paranitrophenol, you know, it is associated through intermolecular hydrogen bonding. There is intermolecular hydrogen bonding. Okay? So this intermolecular hydrogen bonding leads to high boiling point. Boiling point is high, and it is steam non-volatile. So we can separate orthonitrophenol from paranitrophenol by steam distillation. Now see, phenol on treatment with dilute nitric acid at room temperature gives a mixture of P and Q. And it is written boiling. See, out of these two, one is P, other is Q. Now it is written boiling point of P. Boiling point of P is lower than that of Q. That means first one is, yes, ortho is P and para is Q. Done? Up to this. Now P on reduction with SnHCl. Now there is a reduction of P. Yes, SnHCl, FeHCl. We can use them H2PD even. SnHCl. Which one is best to reduce nitro group to NH2? Which group is which reagent is best? It is FeHCl. Why is it so? Yes. And here iron used is only the, which type of iron is used? Scrap iron. You know, scrap iron is very easily available, very cheaply available in the market. So scrap iron is used to produce hydrogen, and therefore NO2 on treatment with H, it gives NH2 and H3, right? And as this H2 is formed, so FeCl2 is hydrolyzed, and we get back HCl. So overall, this HCl is recovered in the process. So only we are using scrap iron. So now, as it is written as SnHCl, so final product from this OH remains as such, and it becomes NH2. Sorry. So ortho amino phenol we will get. Then this is R. Now this R. OH and H2. It is treated with NaNO2 H2SO4. Yes, dihydrogenation takes place. Generally, we are using NaNO2 and HCl, but instead of HCl, here it is using H2SO4. So we get diazonium salt N2 positive, HSO4 negative. So this product formed, nothing is given, followed by the reaction with the excess of C2H5OD. So tell me, what is the role of ethanol in this reaction? Yes, so let us say I will write the simple ethanol. What will we get? Yes, phenol we will get, and therefore this part where this whole thing N2 and HSO4 negative is attached, we have H. This H, right? And now instead of H, here it is D. So we get this product. And at the same time, okay, structure of S we have to excess of C2H5OD is used. See, it is not 1 mole. Excess of C2H5OD is used. As excess of this product is used, you know, phenol is more acidic than alcohol. So there is an exchange, and therefore we ultimately we will get this product. So see, these products mean out of this, so obviously para product we can't get. Ortho, out of these two, obviously this one is the right option. Okay? Let's move to the next question. साथ साथ में ये क्वेश्चन ये रिएक्शंस करते रहेंगे सो दैट हम पूरा चैप्टर भी रिवाइज कर लें और क्वेश्चन भी हो जाएगा. Now we have in this product E. So let us take E here. This is E. Now this E, when it is treated with chlorine, one equivalent of chlorine in the presence of light, what is the product form? This is to NO2. Yes. So what is the product form? CH2Cl. Good. So we get CH2Cl. You know what type of reaction it is? Yes. So keep in mind this helper. बताया था मैंने ये बताया. Helper means heat or high temperature. E for electricity. L for light. Yes, peroxide, electrolysis, or some radical initiator. If these type of reagents are there or these conditions are there, then reaction is free radical. A helper will help you to identify. Okay. So first of all, we have this benzylic chlorination. क्या बोलेंगे इसको? Benzylic chlorination. So benzylic chlorination, we get this F. Now, with aqueous KOH, yes, NO2 remains as such, but Cl is replaced by OH. So this is nucleophilic substitution reaction. So it is G. Now on the other side, oh yes, this is very interesting. See, you know, you have two groups on the benzene ring. One is nitro, which has minus R effect. Other is methyl, which has hyperconjugation. So methyl group will direct the electrophile because Cl2 FeCl3. So it is generating electrophile. It is going to generate electrophile. Cl positive as now this CH3 group direct the electrophile to ortho and para-position. But para-position is already blocked. Now nitro group directs the electrophile to meta. So obviously these are the active positions. But let us say we have methyl and nitro in such a positions that they are directing the electrophile to different positions. यहाँ तो क्या है? Methyl will direct it to orthopara, nitro will direct to meta, and ortho of methyl and meta of nitro are same. So there is no confusion at all. But other different होते हैं, so which will direct, which group we will consider to direct the electrophile? Wrong. The one which is activating, the group which activate the ring will decide. Means the group which has hyperconjugation or plus R effect will decide the orientation of the group. Okay, product. So product is decided by the more activating group. Keep in mind. अच्छा हो गया क्वेश्चन आ गया तो we have that type of क्वेश्चन से ही मुझे लगा कि पूरा चैप्टर अगर एक बार आपने पढ़ लिया है तो बेटर टू रिवाइज इट विद द क्वेश्चंस. हाँ, मुझे द बेस्ट वे इज टू कवर इट बाय प्रीवियस ईयर क्वेश्चंस, है ना? So now your task is to collect the NEST and IAT previous year questions, or if possible JEE advanced question you can touch. Yes, KVPY एक्चुअली वो अभी नहीं आते हैं इसलिए मैंने बोला नहीं, बट KVPY क्वेश्चन भी आपको लेंगे. ठीक है, कौन सा? Okay. Okay, so do collect question from that part also. Huh? So, and collect as many as possible. Okay, so that we can have extensive study. तो सारे चैप्टर का हम ऐसा करते हैं, है ना? चलो, तो now CH3 will decide, right? But because NO2 also give the same product, so undoubtedly we get this product. Okay, there is no confusion at all. So ये हो गया आपका B, next one H. This is H. Now this H will react with aqueous QH and we heat it at high pressure. What is the name of the stage? Tell me. Very good, very good. It is Dow's process. I didn't expect that you can answer it. Very good. You have done this part. So aqueous QH on heating at 623 Kelvin temperature and 300 atmosphere pressure. So we get, instead of Cl we get OK, and then on hydrolysis we get OH. So we get CH3, OH, and NO2. Otherwise, this reaction is very difficult to take place. Yes, but NO2 will help it to carry over. Yes, yes, but at the same time, methyl is also attached. So that will counterbalance the effect of NO2 because NO2 has only minus I effect at chlorine. If it is an orthogonal para, then that its effect is more pronounced. Anyhow, we get I. Sorry, G. This is okay. This is I. Where is that product? Okay, okay. This is G only. मैंने कहीं और लिख दिया क्या? Okay, this is I. Okay, this is I, right? Now, after getting this I, which is CH3, NO2, and OH, in the presence of H2PD, obviously now instead of SNHCl, he is using H2PD. But outcome is same. NO2 is turned into NH2. Okay, so this is J. Now, after getting this J from I, again diazotization. CH3, OH, N2 positive, Cl negative. This is K. And after getting K, it is treated with H2O. And on heating. OH. This is also OH, not orthoglycerol. Yes, because instead of H2O, if there is ethanol or phosphorus S3PO2, then we will get orthoglycerol, right? But H2O will give N2 positive, Cl negative is replaced by OH. Okay, so this is JK, this should be L. Okay, now question is, compound G and I are structural isomers. So this is G. And what is I? Yes, so in here it is phenol and this is alcohol. It can be structural isomer, means one type of structural isomer, it is functional isomer actually. This category of structural isomer we can identify that it is functional isomer. So it is right. Now next is electrophilic aromatic domination of compound L can take place even in the absence of FeDrC. Yes, why? Yes. Because you know when we have phenol, we can brominate it in the presence of acetic acid. There is no need of FeDrC because phenol is highly activating group. I mean, OH is highly activating. Sorry. Uh, yes, yes. Bromine in CS2, bromine in water. That is with NH2 as well. So we get para-bromo product. With bromine water, we get 2,4,6 tribromophenols. White PPT, right? So bromine in CS2, we get this product. Bromine in water, acetic acid, or we can use even simply CS2 we can use. And if we use, yes, if we use bromine water, and this is even a test for phenol because this 2,4,6 tribromophenols has quite precipitated, right? Okay. So this is also right. Next is presence of NO2 group in compound H. Facilitate the conversion to I. NO2 in H. NO2. It facilitates the reaction, right? But you know, see, actually there is a glitch in it. What is that? NO2 is meta to this Cl. If it is at ortho and para position to chlorine, then that will affect. थोड़ा थोड़ा बहुत इफेक्ट होगा बी मींस दिस इज कंट्रोवर्शियल स्टेटमेंट एक्चुअली ओके सो मतलब अगर इसको हम यस भी करेंगे तो यस दिस इज राइट स्टेटमेंट बट इसने मुझे लगता है कि जो भी जिसने भी ये मतलब आंसर की बनाई होगी उसने ये सोच के देखा होगा कि NO2 इज अ मेटा पोजीशन बट एटलीस्ट even at meta position there is a minus I effect थोड़ा बहुत इफेक्ट तो रहेगा ठीक है now next is conversion of compound J to compound K involves nitration of C J to K okay J to K there is no such reaction right because the nitration हो रही है अच्छा हाँ 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 सिंपल नाइट्रेशन ऑफ जे के लिए हमें अच्छा इन NaNO2 सोच के कि किसी को चाहे बिल्कुल ही नॉलेज ना हो तो उसको तो ये तो बिल्कुल ही रॉन्ग स्टेटमेंट गॉट इट okay so let's move further this reaction we have done I think we have covered in the phenol chapter 3 aldehyde ketone carboxylase ओके। हम्म। हाँ हाँ हाँ। तो आपको आइडिया कीटोन कार्बोनिक एसिड के भी अगर मिलेंगे आपको तो ऐड कर सकते हो आप ऐसा करो कोई ऑर्गेनिक ही कर लो। बट क्या है कि अगर आप सेपरेट करोगे ना तो हमें क्लियर होगा कि हाँ चलो ये पोर्शन हमें आता है। थोड़ा मतलब एक आइडिया लगेगा कि ये कौन सा पोर्शन वीक है या कौन सा स्ट्रॉन्ग है ना? तो यस यस। हाँ वो सही है, पर जैसे ये क्वेश्चन है आप देखो, तो ये दोनों चैप्टर में आ जाएगा, हेलोरिन हेलोरिन में भी और अल्कोहल फेनोल ईथर में भी। तो आप ऐसे क्वेश्चन मतलब थोड़ी बहुत डिमार्केशन हो सकती है, तो जितना हो सके करना। अदरवाइज वो एक जो पैकेज होगा उसमें डाल देना कि सारे चैप्टर हैं इसमें, है ना? ओके, सो हियर वी हैव ब्रोमीन्स and aqueous KOH. So obviously, you know, aqueous KOH will means do nucleophilic substitution reaction. Br is replaced by OH. But yes, if it is aromatic, you know, there is a double bond character, and if it is vinylic, not allylic, if it is vinylic, again there is a double bond character. So see, this is vinylic, this one is aryl, aromatic halide, but these two can be easily replaced. So we have identified these two. So these two are replaced by what? अच्छा, ऐसे क्वेश्चन में ना आपको पहले ऑप्शन नहीं देखने, क्योंकि जब हम ऑप्शन देखते हैं ना तो हम फिर वहां पे इधर 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 ऐसे देखने लगते हैं। आप पहले ही प्रोडक्ट बना लो, क्योंकि अगर आपके दिमाग में फिट होगा कि ये दो रिप्लेस हो गए खत्म बात, तो फिर आप इन दोनों पे ध्यान दोगे कि चलो फर्स्ट ऑप्शन पे आए, ये ओएच रिप्लेस है, ये नहीं है रिप्लेस, खत्म, ये नहीं होगा। इसमें ये ओएच रिप्लेस है, ओके डन, ये रिप्लेस है, ओके डन, ये रिप्लेस नहीं है, ओके डन, बट ये रिप्लेस हो गया, नहीं होगा। इधर ये OH, ये OH ओके, ये Br ओके, दैट मीन दिस इज द राइट ऑप्शन। ऐसे करना है, मतलब पहले आपको फिट कर लेना माइंड में कि ये दो देखने हैं मुझे। ओके, कंसीडर द फॉलोइंग कंपाउंड्स। This Canton is saying in both the in all the four compounds, say this part is same. So that means we will look at these groups. Here it is hydrogen. These are the groups. See here in first case, not minus high. In this case, there is hyperconjugation. Here there is a lone pair. Here it is plus R. Here it is, and here no effect. Right? Now, you know, correct order of rate of acid catalyzed dehydration. So tell me, when dehydration takes place, what will happen? First of all, this becomes protonated alcohol. H plus ion will attack on OH, and after the attack, what will happen? There is a yes, there is a removal of OH, and carbocation is formed. So we will only see the stability of carbocation because in acid catalysis dehydration, stability of carbocation is the rate determining step. So now, which carbocation is most stable? Obviously, the groups which have more plus R effect, means more releasing effect, that makes carbocation more stable. So R is most stable. That's why its dehydration is maximum. Then P and then Q and at the end S. Because NO2 group withdrew electrons, therefore intensify the positive charge. That's it. So just compare RPQS. In this case, even you will not look at the options first. Just make an intelligent guess and then make adjustments accordingly, according to the options. कई बार क्या होता है आर पी आ गया पर आपने एस क्यू कर दिया गलती से तो देखो आर पी आर सबसे ज्यादा है तो एक ही है जिसमें आर सबसे ज्यादा है तो यहाँ से आपको आइडिया लगता है जो ओके मैंने ये अगला गलत किया है चलो चलो आर के क्यू पी कर दिया तो भी आपको पता चल जाएगा ठीक है ओके विलियमसन ईथर सिंथेसिस first what is Williamson ether synthesis so in Williamson ether synthesis we have sodium salt and alkyl halide so we get ROR dash plus NaX and what is the nature of alkyl halide means it is primary, secondary or tertiary or any only primary and it undergoes SN2 type of reaction. So now you can look at the options 1, 2, 3, 4 and at the same time this alkoxide group can be R group here can be tertiary, secondary, primary but alkyl halide should be primary. So see if we take into account first one so obviously on one side this is tertiary group so that implies it should be sodium salt so other part becomes this one and here should be some halogen but reaction cannot take place because there is double bond character That means first cannot undergo Williamson ether synthesis. Now come to the second one. So obviously, if you look at it, it is benzene ring. So halogen cannot be on the aromatic group. So it should be sodium salt. So other will be again same vinyl halide. Again there is double bond character. So that means first and second cannot be the right options. So we left with third and fourth. First, second, third, second, fourth. So that means only third, fourth is the right option. Now look at the third and fourth option. See, we have this part. So this part will be sodium salt. Sodium salt, because if we attach halogen here, that becomes tertiary aldehyde. But on the other side, we have this one. Obviously, this is primary alkyl halide. So condition is satisfied. On next one, same case, we have sodium salt and alkyl halide. That's it. So third and fourth is the right option. Now next one. Okay, so molten NaOH and heat. If it is molten NaOH and we heat it, we get sodium salt. So this is Q. Now this Q is treated with methyl iodide. So tell me, what is the name of the reaction? Yes, it is Williamson ether synthesis, and we get phenyl methyl ether. So this is our methoxybenzene. What is the name of the methoxybenzene? Common name. This is anisole. Now, same sodium salt is treated with CO2 and H plus. What is the name of the reaction? Yes, it is always synthesis. What is the name of this product? Salicylic acid. And this is always a reaction. So R, and this one is S. So R and S. So R is methoxybenzene. Okay. desoxybenzene and 2 hydroxy benzoic acid, right? So it is option A only. That's it. इतने क्वेश्चन कलेक्ट कर पाए ना हम. तो आप जब भेजोगे तो we will take class and time. Maybe tomorrow if if it's possible. Otherwise, I will. Huh? Okay. Yes, I will see. Bye. Thank you दोस्तों to support my channel. और अगर आपको लगता है कि मैं कुछ कंट्रीब्यूट कर पा रहा हूँ आपके नॉलेज में ऐड कर पा रहा हूँ तो प्लीज डू सब्सक्राइब माय चैनल. थैंक यू सो मच. गॉड ब्लेस यू ऑल. हैप्पी लर्निंग.